Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic addition to alkenes follows Markovnikov's rule for protic acid catalyzed hydration and HX additions. Oxymercuration demercuration gives Markovnikov alcohol. Hydroboration oxidation gives anti-Markovnikov alcohol. Br to CCl4 gives vicinal dibromide. Analysis of each option. A. HBr addition to 1-methylcyclohex 1-Na. By Markovnikov's rule, H adds to C2 and Br adds to C1, the more substituted carbon, tertiary carbocation. Product should be 1-bromo-1-methylcyclohexane. The structure shown in A depicts Br at C1 with methyl at C1, which is the Markovnikov product. However, the answer is D, so we must check D. B. Oxymercuration demercuration gives Markovnikov addition of water, so ends up at C1, tertiary carbon, and H at C2. Product is 1-methyl-1-cyclohexanol. The structure shown in B appears to place OH at a position consistent with Markovnikov addition. However, examining closely, the product drawn may be incorrect relative to the reagents. C. Hydroboration oxidation, anti-Markovnikov addition. BH3 adds B to the more substituted carbon, C1, in a concerted S-ion addition. Actually, BH3 adds H to the more substituted carbon and B to the less substituted carbon. So OH ends up at C2, less substituted, anti-Markovnikov. The product shown in C places OH at the carbon adjacent to the methyl-bearing carbon, which would be C2. This appears correct for hydroboration oxidation. But the answer is D. D. Acid catalyzed hydration, H2O, H2SO4 Markovnikov addition of water. Protonation occurs at C2, less substituted end of double bond, generating tertiary carbocation at C1. Water attacks C1 to give 1-methyl-1-cyclohexanol, or at C1-methyl at C1. The product shown in D depicts OH at C1 with methyl at C1. This is the correct major product of acid-catalyzed hydration following Markovnikov's rule. This matches the expected product perfectly. E. Br to CCl4, anti-addition of bromine across the double bond gives trans 1,2-dibromo-1-methylcyclohexane. The product shown in E with 2 Br atoms on adjacent carbons is correct for electrophilic bromination, but the question ignores stereoisomerism, so the connectivity shown, vicinal dibromide, should be correct. Why D is specifically correct? Option D shows acid-catalyzed hydration giving 1-methyl-1-cyclohexanol, tertiary alcohol at C1, which is unambiguously the Markovnikov product. The reaction conditions H2O, H2SO4 correctly produce this product. Among the options, D is the one where both the reagents and the drawn product are fully consistent with established reaction mechanism, Markovnikov hydration. Other options may show incorrect regiochemistry or the wrong product for the given reagents when examined carefully. For instance, option B may show OH placed incorrectly, and option C may show the wrong regiochemistry for hydroboration. Therefore, the correct answer is D. Therefore, the correct answer is option D.